Good morning, children. Stay healthy and safe and stay at home. So, I am starting the first chapter of 10th standard, that is force. The chapter name is force. Okay. So, what is force? You know that force is what? It is an external effect which can cause the state of change, or it may tend to change the state of rest or state of motion of a body, and it can also cause, or it can also change or tend to change the size and shape of a body. Alright, that from lower classes you are studying what is force. Force means the push or pull that you studied in the lower class, but in the higher classes we do not say that force is the push or pull. We say this is the external influence or external effect which changes or tends to change the state of motion of a body or the size and shape of the body. Alright, that is known as force. So, here in this chapter we will study what are the different effects of force and what kind of motion a body can have when a force is applied on it. Now we know that a body can have generally the two kind of motion. One is known as the translational motion. Another one is named as rotational motion. Okay. So, what kind of motion a body can have when you are applying a force? The body may have translational motion or the body may have rotational motion. So, one by one I am discussing what is it. Now, what do you mean by the translational motion? That you have to understand. Translational motion a body will have when the entire body is free to move. Alright, what does it mean? That no part, no point of the body is fixed or rigid. The entire body should be able to move. Then only when you are applying the force you can have translational motion. So, we have to understand what is translational motion. It means that, just you consider this example, this is translational motion I am discussing. Suppose you have taken one body and I am considering 2 points on the body. Let us name it as A and B. Is that clear? Just we are considering 2 points on the body. Now, when you have applied a force on it, okay, suppose the body is moving in such a manner, you see, after the application of the force, the body has come from this position to this position. And what about these 2 points? These 2 points, you see, it has come here and B has come here. So, if you join A dash means the 2 positions of the point you have considered, then if this, let me first draw. So, if these 2 lines, when you are joining the 2 positions of the points under consideration by line, if these 2 lines come parallel to each other, okay, then you can say that the body is having translational motion. So, just understand it. Suppose after application of the force, the body has come here. Then, after some time, the body has come here. So, you see, now, what is the position of the point A I have taken? It has come here. So, if I join them, the position of the point A, okay, if I join it by a line, I am getting this line. Then you see, what about the point B dash? B double dash has come here. When the body has come here, what about the point B? Point B we have taken, it has come here. So, if we join these 2 lines, these are parallel to each other. Then we say the body is having translational motion. Alright, so if you look at the path, just look at the path here. Okay, the body has gone like this, then body has gone like this. Is it a straight line? No. If you consider the entire path, it is not a straight line, but just it is almost curved. Isn't it? In that case also, we can say it is a translational motion. Because it is my experience, this translational motion means as if the body is moving along a straight line. Not necessarily. Translational motion may have along one straight line, may be along one curved path, but these condition has to be satisfied. What are the condition? That if you join the position of the particles on the body for its different positions, then the lines we are getting that should be parallel to each other. Then only we can say that the body is having translational motion. Is that clear? So this is the concept of translational motion. Now on this topic, what is the probable question? The probable question is that under which condition a body can have translational motion. Alright, there are 2 points for that. What are the 2 points? That one force should act on the body. What does it mean? That resultant force acting on the body should not be zero. Alright. Secondly, the entire body should be free to move. So, how to write this answer point wise in the board exam or in any exam if the question comes that under which condition a body will have translational motion, this is the condition that entire body should be free to move, and secondly that resultant force acting on the body should not be zero. Alright, now second one is rotational motion. When a body will have rotational motion, when one point or an axis or a line on the body is fixed. Alright, just you consider this example. Suppose I am drawing this one. Here you see I have drawn a discontinuous line. Discontinuous line means what? I have taken the line or perpendicular to the plane of the body. So you see, if you consider this hand, my palm is the body, then this line, it is perpendicular to the plane of the body. So when we draw in the diagram, because I am drawing a 3-dimensional diagram on a 2-dimension one. So you see, this one you have to take care that if you draw this line continuous, it means, just you see, if I draw the line continuous, it means that the line is on the plane of the body. Is that clear? But if I draw a discontinuous line like this, it means that the line is perpendicular to the plane of the body. So you see this point, okay, suppose I am naming it as O. This point is fixed of this body. Unlike the translational motion, entire body is not free to move. One point is fixed. Alright, it may happen that one line of the body is fixed. The most common example is the door. You have seen that the end corner of the door always it is fixed. If you consider the page of a book, the page of a copy, then you have seen the point where the pages are joined. There, just I am showing you 1 minute. Suppose you consider this one. So you see the point where the pages are joined, this one. It is fixed. Alright, so one line on the body is fixed, or it may happen that one point is fixed. Alright, so whenever you are having this kind of body and you are applying a force on it, then what will happen? What the force will do? The force will produce a rotational motion. This arrow indicates that the body will rotate about this axis. Is that clear? The body will rotate about this axis. Means the body, just you consider my hand and this is the axis. So if you apply the force like this, then the body will rotate like this. Okay. So this is called rotational motion. Clear? So you see, whenever rotational motion is created by the application of the force, then the first condition is that one point or one line on the body should be fixed. Then only the body will undergo rotational motion. Is that clear? Second condition, resultant moment of force should not be zero. Because if the resultant moment of force is zero, then although you are applying the force, that later on I will discuss in details. So if you apply the force, then also the body may not rotate. Is that clear? So if the question comes that just like the translational motion, under which kind, so you see what is the condition? Just like the translational motion, that rotational motion a body can have. Under which condition a body can have rotational motion? So what are the conditions? That body should be fixed, pivoted. Pivoted means fixed at a point, or one line on the body should be fixed. Secondly, resultant moment of all the forces should not be zero. Is that clear? When you will write down the answer in board exam, then if you underline the keywords, if you underline the main information, then the answer become more impressive, okay, and you may get full marks. So I always suggest those who follow the lectures, alright, that in 10th standard, when you are answering the board exam, after writing one answer, try to highlight the keywords by underlining it. Okay, that's why I have underlined it. So what I said, that body should be pivoted at a point, or one line on the body should be fixed. Is that clear? So these are the two kind of motion a body can have when you are applying the force, that translational motion and rotational motion. Alright, now in lower classes we have studied details about the translational motion. Now I will discuss about the rotational motion. Now in case of rotational motion, only force cannot produce rotational motion. While producing rotational motion, it is also important where you are applying the force. Alright, at which distance from the fixed point or fixed line, which we also call as axis of rotation or point of rotation. Alright, at which distance from the axis of rotation or point of rotation you are applying the force, that is also important in case of rotational motion. In case when you are applying a force and body is undergoing rotational motion, in that case we just define one term in physics, that is known as turning effect of a force. Alright, turning effect of a force, it actually indicates, it measures how easily one force can rotate a body. Alright, it gives the measure that how easily you can rotate a body. Is that clear? And turning effect generally we measure by the term which is known as moment of force. Alright, now moment of force actually is the term which produces rotational motion. Only force can produce translational motion. Alright, it does not matter where you are applying the force. Is that clear? But in case of rotational motion, only force cannot produce. We cannot say that only force is responsible for producing rotational motion. Rather we say the term moment of a force is responsible to produce the rotational motion. Alright, now how we define moment of force, just understand it. Moment of force is product of magnitude of the force. Alright, product of magnitude of the force multiplied by the perpendicular distance of the force from the axis of rotation. You see here, understand it. I have applied the force at the point P. So, what is the perpendicular distance of the point of application of the force from the axis of rotation? That in the diagram I have denoted by D. So, the product of F and D is known as moment of force. And moment of force produces the rotational motion. So, how we define moment of force? Moment of force we denote it by the Greek letter tau. Alright, so I am just showing you how to write tau. This is the way you will write the curve, and then here C. So this is tau. It is a Greek letter, okay? And moment of force we denote by the Greek letter tau always. So here always you must learn, whenever you are learning any physical quantity, you should also try to remember this letter we generally use to denote that particular term. Then what will happen? While writing the answer, your task will be easier. Instead of writing the entire term moment of force, if you write tau, then also it's okay. Is that clear? So what is moment of force? As I said, it is the product of magnitude of the force and perpendicular distance of the line of action of the force, from the axis of rotation. It is denoted by D. So you see what you can write, that tau is equal to F into D. So this is the basic concept. So you must learn what is the definition of moment of force in words also, in symbol also. So I repeat, what is moment of force? It is the product of magnitude of the force and perpendicular distance of the line of action of the force from the axis of rotation. So symbolically we write it as tau is equal to F into D. This also you must learn how to write it. Okay. You see how I have written the term name, I have written moment of force, then within bracket I have written the symbol. Exactly you must do the same while writing the answer or while taking the notes from the lecture. Is that clear? So that in the next step when you are writing that tau is equal to F into D, it is clear what does tau represent, what does F represent, what does D represent. So this is the first point regarding the, not this is the first point, this is the second point, because the first point was condition for rotational motion. So this is moment of force and this is the symbolical representation of moment of force. Now the other points related with moment of force is that we know in physics whenever we learn a new physical quantity, then we should know about it, that whether it is a scalar quantity or a vector quantity. Now moment of force is a vector quantity. Why? Because the moment of force has its direction also. Now, if a body under the application of the force undergoes anti-clockwise rotation, then the direction of the moment of force is anti-clockwise. And if the body rotates in the clockwise direction under the application of the force, then what is the direction of the moment of force? Clockwise. Is that clear? So, moment of force may have two directions, either anti-clockwise or clockwise. Alright. Now, within applying the sense of rotation, we assign means positive sign, negative sign to the moment of force. And this point is also very important concept wise because questions frequently come on this topic. Alright, what is the concept of the sense of rotation? If the moment of force is in the anti-clockwise direction, then it is considered as positive. And if the moment of force is in the clockwise direction, then we consider it as negative. Alright, so another point is, what is the SI unit of moment of force? You know tau is equal to F into D. So what is the SI unit of force? Newton. What is the SI unit of distance? Meter. So what is the SI unit of moment of force? Newton meter. Alright, I have put one hyphen here. If you do not put the hyphen, then you should keep a blank here, because you have learnt in the 9th standard first chapter, unit and measurement chapter, how to write down the unit. When you are writing Newton meter, either there should be a gap between Newton and meter, or there should be a hyphen sign. You cannot write Newton and meter sticking with each other. Is that clear? So sometimes you forget that. That's why I prefer that you put a hyphen. Newton meter. What is the SI unit of moment of force? Newton meter. So what are the other important points you must remember regarding the moment of force? That moment of force is a vector quantity. Moment of force may have the anti-clockwise direction or clockwise direction. Is that clear? Unlike the force, it may not have any direction, only two direction, either anti-clockwise or clockwise. Another point, that anti-clockwise moment of force, we consider it as positive, and clockwise moment of force is considered as negative. And SI unit of moment of force is Newton meter. Alright, now here, this is my experience from last year, that few children, okay, they are, again, what to say, I cannot use any kind of adjective, because then they will be, they will take it in their heart, okay, that your intention is not to write only the notes. Your intention is that you learn the subject, you learn the topic, and that's why I am taking the trouble to make this video. Alright, to make a 30 minutes video, you know that at least 1 hour I need. So I am taking that trouble only for my children, although I do not bother about those who are not interested in studies. Okay, and they just make the tantrum. They say that making the notes. What making the notes? Whatever I will write on the whiteboard, that only you will note down in the copy, and that is enough for the subject. You will not try to understand what is discussed in the lecture. Only you just open the lecture, and whatever is written on the whiteboard, that you note down in the study material copy. That's it. But that is not the way to learn a subject. I'm sorry to say that, but I'm also happy. At least 80% of my students, they follow the lecture properly. Okay, they follow the lecture properly, and not only that, they try to understand the subject. And that is only my intention, that my children, they can understand the subject properly. That's why I take the trouble and make the video. Okay. Now, otherwise, in Google Meet, it is not at all enough to explain due to the internet connection. So here, once again, I am just warning those who are having this habit that whenever one lecture they are opening, whatever is written on the whiteboard, they are just copying and they are writing the notes. Writing the notes is not enough to learn a subject. You have to understand about the topic discussed in that particular lecture. Okay, so what I said, that rotational motion, I am summarizing it. Rotational motion can be created by means of moment of force, not only force. And how we define moment of force? It is the product of the magnitude of the force and perpendicular distance of the force from the axis of rotation. Alright, and that's why symbolically one can write moment of force is denoted by tau. So tau is equal to F into D. D is the perpendicular distance of the line of action of the force from the axis of rotation. Second point regarding the moment of force. Moment of force is a vector quantity. So Third point, automatically the question will arise, what are the directions? Unlike the other vector quantities, moment of force cannot have any direction, It has only two directions, either anti-clockwise direction or clockwise direction, depending on the sense of rotation. Alright, now if the body rotates in the anti-clockwise direction, then the direction of moment of force is anti-clockwise, and anti-clockwise moment of force is considered as positive. And if the body rotates along the clockwise direction, then the moment of force is clockwise directed, and the clockwise directed moment of force is considered as negative. Alright, another point that SI unit of moment of force is Newton meter. While writing Newton meter, be careful, Newton one space then meter or Newton hyphen meter. Newton and meter cannot be written just one after another. Is that clear? That is the point. Next point regarding the SI unit of moment of force. Already you have studied the work energy power chapter. So now it is becoming easy for me. You know that in case of work done, SI unit of work done is equal to force multiplied by displacement. Then it is also coming Newton meter, and then we say that Newton meter is joule. Alright. But in this case, moment of force Newton meter, but you cannot write this Newton meter as joule. Why you cannot write Newton meter as joule? Because you see, in this case, when I am writing the meter, it denotes not the displacement. It denotes the perpendicular distance between the line of action and the axis of rotation, which is completely different from displacement. Alright, that's why while writing the SI unit of moment of force, no one can write joule in place of Newton meter. Alright, you cannot write joule in place of Newton meter. That is the cause. Because in joule, when we are writing Newton meter, meter stands for displacement, but here in case of SI unit of moment of force, meter stands for the distance between the line of action and axis of rotation. That is the reason that one cannot write joule in place of SI unit of moment of force Newton meter. Okay, so these are all important points related with the moment of force. Thank you, children.